Which of the points labeled in the graph below make the system of inequalities with y is less than or equal to negative 5 over 2x minus 2 and y is less than negative 1/2 x plus 2 true? Select all that apply. All right, so of these points that were given here, which are negative 4 and 4, negative 3 and 2, and negative 3 and negative 2, we can just plug each of these points into both of the inequalities and see which of them make both of the inequalities true at the same time. Let's take a look. Negative 4 and 4. Does that make our first inequality true? So our y value is 4, our x value is negative 4. Let's plug these in. Is 4 less than or equal to negative 5 over 2 times negative 4 minus 2? Is 4 less than or equal to, those cancel out, that gives me negative 2. Negative 5 times negative 2 is 10 minus 2. 4 is less than or equal to 8. Yep, that makes this inequality correct. But I can't stop there because it needs to satisfy both inequalities, so let's test it in the other one. Again, y is 4 less than negative 1/2 times negative 4 plus 2. 2 and negative 4 can cancel out. Is 4 less than negative 1 times negative 2 is 2 plus 2. That gives us 4 is less than 4. That is not true. 4 is equal to 4, but we don't have an equal to sign in here, so that does not work. So the point negative 4, 4 does not satisfy both of these inequalities. Therefore, it does not satisfy this system of inequalities. Let's test the next one. Negative 3 and 2. Let's start, we've got our x value is negative 3, our y value is 2. Let's start with the first one. 2 is less than or equal to negative 5 over 2 times negative 3 plus 2. If we simplify that out, we get is 2 less than or equal to 15 over 2 plus 2. And if we continue on to do our calculations, we find, yes, 2 is indeed less than or equal to 19 over 2. So this point satisfies the first inequality. And if we go ahead to do our calculations for the second inequality, it also satisfies the second inequality. So this point, negative 3, 2, is a solution to both inequalities, and therefore it is a solution to this entire inequality system. And if we want to test our final point, negative 3, negative 2, we can see x is the negative 3 value and the negative 2 value is for y. And if we plug those into both of our inequalities in this situation, both of them come out as being true when you plug in negative 3 and negative 2. So that means that negative 3, negative 2 also makes this system of inequalities true. So our 2 points that make the system of inequalities true are negative 3 and 2 and negative 3 and negative 2, but negative 4 and 4 does not make this inequality system true.